Okay, now what is meant by state of a system? We learned first the system, what it is, then we learned about the properties, then we learned about the boundaries. Properties, we are yet to do some more of the properties. We learned about the surrounding. Everything outside the system is called surrounding. The wall between the system and the surrounding is called the boundary. Now we go to state of a system. What is the state of a system? It is the condition of the system which is defined by specific values for a set of properties that characterize the system. That means what? That means a system, say, is consisting of only ice. The phase of water is here solid. What are the properties of the system that we can tell about ice or describe ice about? It is that we are saying ice is having temperature 0 degree Celsius. So, this is state 1. Say state 1 consists of solid ice. The phase of ice is of course solid. The phase of water, we should say, is solid, and it is described by a property, that is temperature, for which we have set a value of 0 degree Celsius. Next we see system 2. State 2. This is a system which is consisting of a glass of water. The phase is liquid water. That has got nothing to do with the property of the system, but we can say that the temperature of liquid water is at room temperature 25 degrees Celsius. Again, if you see a system 3, the state of the system is characterized by a temperature which is 100 degrees Celsius, which means it is consisting of water, and water is in the form of vapor. So, the phase of the component of the substance in the state in the system 3 or in state 3 is water vapor. So, you mean to say system and state are same? No. System consists of matter, and in these 3 cases, and state 1 is of solid phase, state 2 is of liquid phase, state 3 is of gaseous phase. All the 3 states are characterized by temperature, for which we have set values 0 degree Celsius, 25 degree Celsius and 100 degree Celsius respectively. Next, what is properties? We said we need a set of properties to characterize the system, the state of the system. Properties, you know, they can be temperature, pressure, volume, density, heat capacity, mass. Then we have got refractive index. We have also got energy. So many properties that can characterize a system. Properties are again of 2 types, intensive properties and extensive properties. The intensive properties are those which characterize a system and are independent of the mass or the quantity of matter present in the system. The extensive properties are those which will obviously depend upon the extent of the matter in the system. Okay, coming back to intensive properties, we know, for example, temperature. You will see that a small cube of ice will have 0 degree Celsius as its temperature. Similarly, the large chunks or the blocks of ice we see in the fish market or the meat market are also at 0 degree Celsius. So, temperature is independent of mass. Intensive properties are independent of mass. What about extensive properties? Extensive properties are dependent on the quantity of substance present in the system. There are more examples to illustrate this intensive properties. We said temperature is 1. Okay? See here, a glass of water at 25 degrees Celsius, you can say a jug of water at 25 degrees Celsius is having the same temperature as the bucket of water, which is also 25 degrees Celsius. So, amount of substance is not in question here. It is the temperature which is the main factor. Similarly, density. Density of ice, a small block, here you see in the tumbler, small cubes, it is 0.9168 gram per centimeter cube, and if you see the large chunk of ice, it still has density 0.9168 gram per centimeter cube. What about specific heat capacity? It is again constant. It is independent of the mass. If you take such a large bundle of copper wire, the specific heat of copper is going to be 0.0923 calorie per gram Kelvin. In case of a copper bowl, which is made up of solid copper chunk, you can see here, it's a metal, a solid metal here, that is again going to have a specific heat capacity of 0.0923. Okay. Now, why is this so? Why is it that heat capacity is different from specific heat capacity? So, heat capacity, if you recall the definition, you will find heat capacity is the amount of heat which is required to raise the temperature of a system through 1 unit degree, or unit degree. But specific heat capacity is what? It is the amount of heat required to raise the temperature of a unit mass by a unit degree. So, it will always be constant whether you take 5 kilogram of copper or you take 0.05 gram of copper. It will always be with respect to 1 kilogram of copper, and we will specify the specific heat in terms of the same units, because it is going to be per unit per calorie per unit gram per unit temperature. So, next, what about the extensive properties? They are mass. We know very well it depends upon the quantity of matter. The volume, again it depends on the quantity of matter. And what else? Internal energy of a system, that also depends on the quantity of matter. So, we have got any property which depends on the extent of the matter, which depends on the quantity of the matter or the mass of the system, is called extensive property. Done with these intensive and extensive properties, let us see, can we do mathematical operations on these properties? Yes. If you divide one extensive property by another extensive property, you will see that the resultant property is one intensive property. The simplest example is density. See, density is mass upon volume. So, mass is the extensive property. It depends on the quantity of matter in the system. Volume is another extensive property which depends on the quantity of matter in the system. And so, mass upon volume is equal to density, which is now independent of the matter of the system. So, density is an intensive property. We will not say that a bucket of water will have some higher density than a glass of water. Water will always have the same density, that is around 1 gram per centimeter cube.